In this question, it is given that let the set S equal to defined by here, then the value of sigma sine square theta plus pi 4, where theta is belonging to S. That is, first I will find all possible values of theta which will belong to the set S, and those values of theta I will put here one by one, and the answers you will be getting, you will have to add those answers because of sigma. What I mean to say, you will understand when I will do this question. First of all, find the value of theta such that it lies between 0 and 2 pi also, and this condition is also satisfied. And you must be knowing this formula directly. Tan A plus tan B is equal to sine A plus B upon cos A cos B. And if it is minus here, minus will come. It's not difficult to prove this formula, very easy proof. And using that formula, I can write it as sine of pi cos theta plus pi sin theta upon cos of pi cos theta into cos of pi sin theta equal to 0. And that is, I get sine of pi into sin theta plus equal to 0. It means pi into sin theta plus is equal to 0. Pi minus pi only. More values are not possible because we know that the maximum value of this is root 2. Hence the value of this cannot be more than root 2 pi. Hence equal to 0 I have written, equal to pi I have written, but this equal to 2 pi is not possible because in that case the value of this will become 2, which is not possible. And because the minimum value of this is minus root 2, the minimum value of this will become minus root 2 pi. Hence the value of this cannot be less than minus root 2 pi. Keeping these facts in mind, I can say the possible values of this are 0, pi or minus pi only. No other value of this is possible. Hence I will get sin theta plus cos theta equal 0, or sin theta plus equal to 1, or sin theta plus equal to minus 1. Agreed, this part is easy, but solving the value of theta by using this and this separately will make it very lengthy. How to deal with those two, I will tell you, but let me do this thing first. It means tan theta equal to minus 1, and it is given that theta lies between 0 and 2 pi. That is, tan theta equal to tan minus pi 4, that is theta is equal to n pi minus pi 4, and I'll put the values of n and accept only those values of theta which lie between 0 and 2 pi. If I take n equal to 0, not allowed. For n equal to 1, I'll be getting 3 pi 4. For n equal to 2, I'll be getting 7 pi 4. And more values of n are not possible because theta has to lie between 0 and 2 pi. These are the two possible values of theta I have got by solving this. And one thing more, to solve it, finding the value of theta from here and theta from here separately and use those values is lengthy. If I combine these two, I can write it as sin theta plus cos theta whole square equal to 1, because this means sin theta plus cos theta is 1 or minus 1. And now it is 1 plus equal to 1. That is sin 2 theta equal to 0. That is 2 theta is equal to m pi. That is theta equal to m pi by 2. Taking m equal to 0, theta will become 0. For m equal to 1, theta will become pi by 2. For m equal to 2, theta will become pi and 3 pi by 2. Hence, 2 values of theta I have got from here. 4 values of theta I have got from here. Hence, the possible values of theta plus pi 4 are, I'm going to add pi by 4 in all these values. That is pi, 2 pi, pi by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4. Hence, the value of sigma sine square theta plus pi 4, where theta belongs to the set S, as we had to find the value of this. This is equal to, keeping these values of theta plus pi 4 in mind, I'll be getting sine square pi plus sine square 2 pi plus sine square pi 4 plus sine square 3 pi 4 plus sine square 5 pi 4 plus sine square 7 pi 4. Clearly it is 0, 0, 1 by 2. Sine 3 by 4 is, again it is 1 by root 2 whole square. Therefore 1 by 2. And this also minus 1 by root 2 square, that is 1 by 2. That is the answer is 2.